Okay, folks, take notes in your Topic 9 note packets, starting on page 8. Today we're going to look at why the seasons change, and this is a topic that can be a little trickier than you might think. So let's ask some graduates of Harvard University if they know how the seasons change. They must know. They went to Harvard. They're smart, right?
The Earth goes around the sun, and it gets hotter when we get closer to the sun, and it gets colder when we get further away.
Okay, I think the seasons happen because as the Earth travels around the sun, it gets nearer to the sun, which produces warmer weather, and gets farther away, which produces colder weather. And that's the seasons.
How hot it is or how cold it is at any given time of the year has to do with the closeness of the Earth to the sun during the season.
It's a really common misconception that the seasons change because the Earth gets closer to the sun and farther from it. Now, it is true that the distance between the Earth and the sun changes. Now, if you remember from last time, we looked at the orbit being an elliptical orbit around the sun. So we do get closer and farther from the sun. But remember, Earth's orbit has a very low eccentricity, so the amount that the distance changes is actually very small. So there must be something else causing the seasons to change. When the Earth orbits the sun, its axis is tilted 23.5 degrees from perpendicular, and that axis is always pointing in the same direction. So as the Earth orbits the sun, some areas are tilted towards the sun while others are tilted away. This changes the angle of insolation, and therefore the amount of sunlight each area on the Earth gets. Okay, let's go to your notes. The seasons change because, number 1, Earth revolves around the sun. And number 2, Earth's axis is tilted 23.5 degrees from perpendicular, and this changes the angle that sunlight hits the Earth. So let's see how this works. In this animation, you can see the Earth's axis is tilted 23.5 degrees. Now keep your eyes on the North Pole. Notice that as the Earth revolves around the sun, the North Pole is always pointing in the same direction. As a result, sometimes the northern hemisphere is tilted away from the sun, so they get less direct sunlight, and it gets colder there. And at the same time, the southern hemisphere is tilted towards the sun. They get more direct sunlight, and it gets warmer there. Now, as the Earth revolves, notice that the north begins to get more sunlight. That's because the northern axis is now starting to tilt towards the sun, and the southern axis tilting away. And as we continue to revolve, we see the opposite changes now. So as we're revolving, the spot on Earth that gets the most direct sunlight continually changes, and it changes the seasons. So you remember all those Harvard grads who gave the wrong answer for why the seasons changed? Well, by the end of this video, you'll be able to say that you are smarter than a Harvard graduate, because you will know that the true cause for the changing of the seasons is not the distance between the Earth and the sun. Because, as we're going to see, believe it or not, the Earth is actually closer to the sun in the wintertime and farther from it in the summertime. So why does it get warmer here in the summer if we're farther from the sun? It's all about the tilt. Remember, in the summertime, the northern hemisphere is actually tilted towards the sun. We get more direct energy from the sun, it gets warmer. In our wintertime, we're actually closer to the sun. Why does it get colder here then? Because in the northern hemisphere, we're actually tilted away from the sun. Now, we should also mention that if you were in the southern hemisphere, you'll see the opposite. In our wintertime, when we're tilted away, the south is tilted towards the sun. So it's their summertime. And in our summertime, the southern hemisphere is tilted away from the sun. So it's their wintertime. So let's go back to the notes. Earth is closer to the sun in wintertime and farther from it in summer. Here in the northern hemisphere, it gets warmer in the summer because the north is tilted towards the sun, and it gets colder in the winter because north is tilted away from the sun. Now, since the Earth is round, and yes, it is round, don't listen to those flat earthers, since it's round, the sun's rays don't hit every spot on Earth at the same angle. If the sun is more directly above a certain spot, you'll see here that those rays become more focused. In other areas where the sun's rays are hitting at a lower angle, those rays get spread out more, and we'll see that the intensity of the sunlight isn't as great there. At the bottom of your notes, you'll see a diagram showing the sun's rays hitting Earth's surface at different angles. Notice on the left, the sun's rays are hitting at a steeper angle. Notice at the bottom, the sun's rays are more focused. When the rays are more focused, it makes it warmer. Now, if those same rays are hitting the Earth's surface at a much lower angle, you can see that when they hit the surface, they get spread out. So when they're spread out, it makes those rays less intense, and it makes it not as warm there.